All right, today we're learning how to add and subtract rational expressions. Okay, to add or subtract rational expressions, which are fractions, right, we need to throw back for a second back to regular fractions themselves. So for instance, if I had a couple fractions I wanted to add together, like 1/2 and 1/4, right? So if we think back to when you thought of these as like pies, right? Well, we've got half of a pie, and then we've got 1/4 of a pie, right? And we're adding these things together. We're trying to put them in one pie tin together. So if we do that, we need them to be in the same size slice, right? So in this case, 1/2 we can turn into, or if we look at our two denominators, I should say, 2 and 4, when we think about their multiples of 2, 2, 4, 6, 8, etc. And multiples of 4, 4, 8, 12, 16, etc. Where is the first place they meet? This is called the least common multiple. In this case, I can see 4 is the first place they would meet, right? There are other places they meet. I can see 8, right, as well. 16 would be another place they meet. 12, of course, as well. So lots of places where they would meet, but the least common multiple is 4, and we're calling that the least common denominator. So what I would want is to break these up into having sizes of fourths, right? So I want them to both be over 4. Okay, well, our first pie was already cut into fourths, right? We have our 1/4, so we can keep that one the same. But our second fraction only had a denominator of 2, right? So we're going to need to multiply this top and bottom by 2, which would give me 1 times 2, or 2 up top. And essentially what we're doing is we're dividing this pie now into fourths, and our equivalent fraction we've made, 1/2, is equal to 2/4, right? You can see it's the same size. So now we can add them together. And remember, when we're writing our answer, we're writing them in that common size, the fourths, and then we're putting how many of those pieces we have. Well, we have 2 plus 1 more, gives me a total of 3/4, right? That's our final answer. Okay, so just as a throwback to fractions and what we're doing, why we need common denominators, right? To add or subtract fractions is we need them to have that same size slice. All right. To find the least common denominator, we're going to have to look at all of our denominators. We're going to look at all of their factors. Okay, so step 1, find the least common denominator between all fractions. Step 2 is to make the equivalent fractions like we did here. Okay, multiply the top and bottom by any missing factors from the common denominator. And then we're going to go ahead and add or subtract the numerators, right? Like we added 2 plus 1 to get our 3, and kept the common denominator of 4, right? You don't add the denominators, you keep the common denominator. Okay, so let's find the least common denominator for each of these and add and simplify. So our first one, very similar to what we just talked about, has just numbers, 4 and 8. And I might be able to think about multiples of 4 and multiples of 8, right? There's some multiples of 4, multiples of 8, and I can see that they will meet multiple times, but the first place their multiples would meet is at 8. Okay, so this is one way of coming up with our common denominator, and it is 8 for the least common denominator. Okay, now another way of coming up with this, and this will help us when we're looking at expressions, is what if I broke each of these down? So if I took 4 and I broke it into its prime factors, 4 breaks down into 2 times 2. 8, if we broke it into its prime factors, so you can imagine doing like a factor tree, okay, ends up giving us 3 2's. 2 times 2 times 2 is 8. So kind of a long-winded way of finding this least common denominator is I could look at what do they already share in common. And I can see they each already have a 2, right? So there's at least 1 2 in common. We're going to put that in our LCD. We have a second pair of 2's in common. So we're going to go ahead and put that in our LCD. And we're only putting it in, notice for the ones that they share, we're just putting them in once each. This will help ensure we get the smallest possible common denominator. Now there is one more factor that wasn't shared by each of these, And that factor we cannot get rid of. We need to also include that factor of 2 in our least common denominator. Now, if we multiply these all back together, we would get the same LCD of 8. Okay, so either way, for this particular one, our least common denominator is 8. Okay, with numbers, usually it's a little bit easier. With expressions, we may need to break them into their factors and check to see what they already have in common. Okay, so let's figure out how to make the equivalent fractions, right? Give them those equivalent fractions like we did earlier. Well, our first fraction has a denominator of 4. What would we need to multiply it, top and bottom, to get to our common denominator of 8? We need to multiply by 2. Okay, so we multiply top and bottom by 2. I should really be using parentheses there. And we end up getting 3 times 2, or 6 up top. That's my new numerator, 6. Okay, what do I need to multiply the second fraction by to get to my common denominator? We could say by 1 or by nothing, but in other words, we don't need to change the numerator at all. Okay, so now to add these together, remember we add or subtract the top. 6 plus 5 is 11, and keep the common denominator. 11/8 is our final answer. So our least common denominator was 8. We've added, and now can we simplify 11/8? No, the top and bottom don't have any common factors, so we can't reduce. Okay, let's try number 2, which now has more expressions to deal with. Okay, we have 3x and 6. So we're going to look at this a little bit more like the second method we did the LCD. If I break down 3 and x, well, 3 is prime, and it's just being multiplied by x. We'd say these are the 2 factors from our denominator. 6 is 2 times 3. Those are the prime factors of 6. So to find the smallest possible common denominator, the least common denominator, we're going to look at anything they already have in common. So I look between their factors, and I notice that they both have exactly 1 3. So we're going to put that 3 in our LCD. That's the only thing they share. So what are some things they have that are not common? Well, they have an x, which also needs to be in our LCD, and there's a 2, okay, which also needs to be in our LCD. So anything that's shared just goes in exactly 1 time, every time it's shared. And any non-common factors, things that weren't shared in common, also have to appear in there. In other words, we can't just get rid of any factors. We just don't want to list repeated factors more than is necessary, right? We only wanted 1 3 in here rather than 2 of them. All right, so our least common denominator, if we multiply those back together, 3 times x times 2 is 6x. There is our least common denominator. So let's set up our fractions with that least common denominator, 6x. Okay, so now we need to figure out what do we need to multiply the top and bottom by to get to our common denominator. Well, this has the 3 and the x, right? To get to 6x, I would need to multiply by 2. And you might note this has the 3 and x, it has 3 and x. The only factor it didn't have was 2. And that's what we'll need to multiply by top and bottom of, the kind of missing factor, or the one factor it didn't have. So we multiply the top and bottom by 2, and we get 10 over 6x. There's our equivalent fraction. Our second one, we've got the 6, which remember is 2 times 3. So it's got the 3 and the 2, right? It's missing x. So we need to multiply top and bottom by x to get to 6x. And x times x makes x squared. Okay, now remember we have our equivalent fractions. We get to keep the denominator, 6x, and we can add the numerators together. Well, unlike in the previous problem, these are not like terms. We can't actually combine them, but I can write them as x squared, positive x squared, and positive 10 added together. Our last step would be to see if we can maybe simplify this, but there's nothing I can factor out of the top. And because there's addition or subtraction, that means I cannot cancel with anything in the denominator. If the top doesn't factor out, And the top and bottom don't share common factors. Remember, we cannot simplify. So this is it. X squared plus 10 over 6x. And our least common denominator was 6x. Okay, so let's try this again. Example 3 here, we have some denominators that need to be factored. In our first one, we have a common factor of x in both terms. So we're going to divide that x out of each term, which would leave me with x plus 3. Okay, so there's our first fraction. Our second denominator just has x, so there's no factoring we can do there. So when we go to list our least common denominator, let's look for any factors they already have in common. So remember, here we have two factors, x times x plus 3, and then we have just x. So in this case, they do share an x in common. I guess I should say equals. So we're going to list that x exactly once, right? But there is one factor not common to both of them. And remember, we cannot get rid of any factors. So x plus 3 needs to also be in here. So we just need one x, the shared x, and our extra x plus 3. Our least common denominator is x times x plus 3. Okay. So that's the denominator I want them both to have. We're a little lucky this time. Our first one has that exact denominator. So we don't need to change the top at all. Our second one, though, does not quite have our common denominator yet. It does have the matching x, right? But it's missing x plus 3. So we're going to go to that factor and multiply top and bottom by x plus 3. Okay, now here, notice that we are using parentheses like we should. And we do need to distribute that 10. 10x plus 30. Okay. Now don't try to factor this back out. I want to go ahead and try to add these together first before I try any final simplifying or factoring. So 5 plus 10x plus 30. We can combine the 5 and the 30 up top. We get 10x plus 35. And the bottom, x times x plus 3. Now we can try to see if maybe the top factors further, and I do see a common factor of 5 that we could take out of the top, which would leave me with 2x plus 7 if I divided a 5 out of these two terms. And in the bottom we have x times x plus 3. So again, we're just doing this step to see if maybe any factors in the top and factors in the bottom could cancel out. And in this case, they can't. There's no common factors. So there's my simplified answer. Okay, and there's our least common denominator. So at some point I should note that these do all have domain restrictions like in our other lessons. I'm just not focusing on them at the moment. Of course they are still there, like x can't be 0 or -3, but they do still exist. We're just kind of focusing on the fractional part, focusing on that for today. But I should notate that they do still exist. Yeah, let's do number 4. 5 times x is just 5 and x for our denominators there. Not a whole lot we can do with that, but maybe I'll think of that as 5 times x. 15 can be broken down. That's 3 times 5. And then x squared is x times x. Okay, so to find our smallest possible common denominator, our LCD, let's see what they have in common. I see a 5 that's shared, so let's throw one 5 in there. I see an x that's shared, so let's throw in one x. And then our 3 and remaining x also need to be in there. Remember, we can't get rid of any of these. So multiplying all those back together, 5 times 3 would make 15. X times x, x squared. The LCD is 15x squared. So let's set up those denominators and figure out what, if anything, we need to multiply the top and bottom by to get there. So our first one here, what do I need to multiply top and bottom by to get to 15x squared? Well, 5, we've got the 5 and the x, right? I mean, these were shared. It's missing 3 and x, though. We need to multiply top and bottom by 3x. That makes sense. That would give me 15x squared in the bottom. Now, we do need to distribute the 3x. So we get 3x squared plus 3x. And then our second fraction already has the common denominator, right? We kind of started with it. It's got all of the factors we need, so we don't need to change that expression at all. So let's go ahead and add them together. We can combine just these two like terms as we add. So we'll get 3x squared. Adding those gives us 4x minus 3, all over 15x squared. Now maybe the quadratic up top factors. Remember, a good check for this would be if I just multiplied my 3 over, that would make 9. Are there factors of 9 that subtract to 4? No factor pairs of 9 subtract to 4. So the top is actually not factorable. That's good. We don't need to waste our time trying to factor it. So there's my LCD, and there's our final answer. Okay, a few more problems. Let's do some subtracting. Okay, and remember that subtracting is just the same as adding the opposite. Okay, so all we're going to do when we have subtraction between these instead is we are going to change this to adding the opposite. And we're going to do the opposite of the top. And that does mean sometimes we're going to need to kind of distribute this negative sign. Okay, so this is a good problem where we can see we would need to do that. That minus sign does apply to both the x and the 1 up top. Okay, let's find our LCD though by factoring our denominators. So in the bottom, if you x factor this, the two numbers that multiply to 20 and add up to 9, multiply to 20 and add up to 9, both positive, are 4 and 5. Okay, there's our two factors from our x factor. Our second one, now remember we made this addition already. And up top, this is going to be negative x minus 1. And let's go ahead and factor this. Factors of 12 that add up to 7 are 4 and 3. And I believe they are both positive here as well. Okay, so just doing an x factor there. That's what that one factors as. So let's find our least common denominator looking at our two denominators. They share an x minus 4 already, so let's put that in there once. But that's all they share. So we need to also list x plus 5. Remember, again, we can't get rid of any of these. And an x plus 3. So my least possible common denominator needs to have all 3 of those factors. So we're going to have some larger denominators here. We need to have an x, whoops, I wrote plus 4, apologies there, that should say plus 4, x plus 4, x plus 5, and x plus 3. Okay, this is the denominator we want them both to have. So they're in that same size slice. Okay, now we got them all set up. Let's figure out what we need to multiply by to get there. Well, this has the x plus 4 and x plus 5. It's missing x plus 3. So let's multiply top and bottom by x plus 3. Okay. We will need to distribute here, which gives me x squared plus 3x. Our second one has the plus 4 and plus 3, x plus 4, x plus 3. It's missing x plus 5. So let's multiply that one top and bottom by x plus 5. Now up top we may, in fact we will need to kind of FOIL these out. So you do need to put parentheses around this numerator as well. So if we FOIL this out, that makes negative x squared. Negative x times 5 is negative 5x. Negative 1 times x is negative 1x. And negative 1 times 5 makes negative 5. Okay. So here are our two where you can finally try to add the numbers up top, or the expressions up top. So let's go ahead and do that. And keep our common denominator with all of these factors in it. And now let's combine what we can up top. Positive x squared and negative x squared, when we add those, actually cancel. Right? We get 0x squared. 3x, and those two make negative 6x. So 3x, negative 6x makes negative 3x. And lastly, all we have over here is this negative 5 at the end, minus 5. And I don't think there's anything we can factor out of the numerator here, so I think that's it. There is our final answer. This is what we get when we try to add them together. Found a common denominator, made our equivalent fractions, we combined what we could up top, and that's our final answer. No further simplifying. Okay. All right, let's go ahead and do number 6, last one here. Now, note again, we have subtraction. So let's change that to adding the opposite of our second fraction. And then let's see if we can factor. Well, this first denominator does not factor, but let's go ahead and put some parentheses around it and think of it as its own factor. Now our second one maybe doesn't look like it can factor, but it's so closely related to this one. If I can change that to a positive x and that to a negative 4, they'd match. So a way we can do that is you can factor out a negative 1 from these two terms. Divide out a negative 1. That would make my x positive and my 4 negative. I'm going to go ahead and write my negative 7 up top here. But these are two denominators, and they're very, very close. Right, as we list our least common denominator, they already have an x minus 4 in common now. And the one thing they don't share in common is that negative 1. So I think that's the first place we can make them meet. So they'll both need a negative 1 times x minus 4. Those are two denominators here. And our second fraction, of course, already has that denominator, so no change necessary. But this one is missing the negative 1, right? So we need to multiply top and bottom by negative 1. Whichever side you want to write that on is fine. And we end up with a negative x squared. So keeping our common denominator. And we can't actually add those two numerators together. X squared plus negative 7 is negative x squared minus 7. You could leave it like this. If you wanted to, you could factor out that negative sign from the top. You could do a little extra work. I would leave you with positive x squared plus 7. And then you can kind of cancel the negative 1 in the top and bottom, and it might look a little cleaner. X squared plus 7 over x minus 4. Something like that. Might be a slightly nicer looking version of the same answer, but they are both essentially the same. So that's it. Our least common denominator, negative 1 times x minus 4. So the goal here is factor all of your denominators out. Check for anything they have in common. Whatever's common, list in there exactly once, and then list all of your uncommon factors. Then go back through, figure out what you need to multiply each by to make your equivalent fractions, add or subtract the numerators, keep your common denominator. And then if you can, check and see if maybe you can factor something out of the top and simplify. Most of the time the answer is no, but every once in a while you can. So it's always good to check.